We often draw a free body diagram when we're trying to figure out what's going on with a beam. And structures class, as we have been saying, is really statics class. We are studying statics in this class. And in statics, we pretend that our beams and our columns and all of that are rigid. They're not really. It turns out that everything in the world, every material, every structure is in fact elastic. And next term, if you go on to take strength of materials, we'll acknowledge that, yeah, okay, everything's elastic. But for the purposes of looking at forces in the study of statics, engineers act as if those beams are rigid. And a free body diagram is called a free body because you take the body, like the beam here, and you pull it free of anything that's attached to, the ceiling, the wall, whatever, the wheels, and you just show that body, that beam, let's say, with the forces and reactions. So you've isolated that beam or whatever it is. But as you have observed over time, those reactions can be up and down, like you find on a beam, or the reactions can go at angles, like along this boom here or along this cable, like you did last week. But today we're going to think about, okay, what if we have a simple beam with some supports at the end? What do those look like? So we'll draw the free body diagram if we're figuring things out. We isolate that body, we pull it free of everything else, and we draw arrows. And we need to think about what kinds of supports are there at the ends of this beam. There are 3 types of supports that you will encounter, and which type you have will determine how many of these reaction arrows you put on there. The 3 types are roller, pin, and fixed. And so let's look at what these are. And I should mention that when you see these arrows with a diagonal line through them, that's a device that the author of our book is using. These are pictures from our book. He uses that to indicate he's showing a reaction. So if he's drawing the force or the load, he'll just make a plain arrow. If he's showing an equal and opposite reaction, he'll put a slash through it. So that's what those are about. All right, so in any building or bridge, you can't have all of the ends of the beams fixed in place without any ability to move, because what happens in the wintertime? It gets cold and things shrink. What happens in the height of the summer? Things get hot and they expand. And if you don't have a way for those beams and other pieces to move a little bit, you are going to have buckling and all kinds of bad things happen. So you will notice in, let's say, bridges, you'll notice that bridges have sliding things on one end of each of their beam members. This sliding thing can be called a roller or a rocker, kind of depending on what shape it is. Picture a roller skate on the floor. It can slide side to side, so there's no resistance in the X direction. That thing can slide. It can't move down because the floor is there. So there is a reaction in the Y direction, and you can see he has drawn these Y reactions here. So the floor pushes back in the Y direction, but there's nothing stopping that thing from rolling in the X direction. And there's nothing keeping it from rotating either, so there are no resisting moments pushing back. Well, in some buildings and bridges, you see this in the form of a rocker, where we say it can move side to side in the X direction. Yeah, I know it can't move very far, but it can move some. So there's only a resistance, there's only a reaction in the Y direction. And you'll see these rockers under bridges frequently. Here are some pictures of them. Here's one in a book illustrated with a drawing. Here are some rockers, and I've tried to zoom in a little bit close here in the upper picture. I don't have the best camera in the world, but that is a rocker, and you can see these rockers if you are on Coburg Road in Eugene and you're standing off on a sidewalk somewhere and you're looking up at this overpass where I-105 goes over the top of Coburg Road, and those are those rocker connections on one end of each beam. You also find roller connections or roller supports under bridges and building beams. And again, they can slide in the X direction. There's only a reaction in the Y direction. And other things that can slide are also considered rollers. So you might have, he's drawing here, a neoprene pad, a rubbery pad under this end. Or here's a thing in a connection in a bridge with interlacing fingers that can slide. Those are all considered rollers. A pinned connection you might draw like this in the upper left corner, where you have some kind of ear with a bolt through it, let's say, or whatever it is. That beam cannot move in the X direction and it cannot move in the Y direction. So it cannot move side to side. There is an X reaction. And it cannot move up and down. There is a Y reaction. So it can rotate. There's not a resisting moment, but there is a reaction in the X direction and a reaction in the Y direction. Here's this same overpass on Coburg Road in Eugene, and right here, just so you can get oriented if you want to go look at these, right here is where you will see those pinned connections, and here I've zoomed in a little bit so you can see the shape of it. So on each of these welded steel beams on this overpass, one end has a rocker and one end is pinned. So when it gets hot in the summertime, one end of that beam is free to slide back and forth a little bit. Here are some other pinned connections. I included those just because it's really clear that those are pinned. This one is a pedestrian bridge in Eugene. This one is a really big pinned connection at the bottom of some kind of bridge. These are pinned connections also. So here we see a framed connection in structural steel. This is a bolted connection where a structural steel beam is welded to a column with these framing angles. And believe it or not, these are considered pinned connections. They are not free to move side to side, and they are not free to move up and down. They can rotate a little bit, so there's no moment reaction. And I think you can say they're free to rotate a little bit just because these connections have oversized holes, 1/16 of an inch bigger than the bolt. So these are pinned connections also. And if you put a ladder in some gravel or on some rough concrete, that functions as a pinned connection too. So think about, by comparison, what if you put the end of a ladder on a smooth, polished, waxed floor? You would not want to climb on that ladder because although there is a Y reaction, so it can't go down into the floor, there's no X reaction. That thing can slide away. However, if you put the end of the ladder on a rough surface like some textured concrete, there is a Y reaction and there's also an X reaction. So this kind of support is considered a pinned connection too. The third kind of connection or support condition is called a fixed connection. And this is what you have when you have something that's maybe cast in concrete. Here's a beam cast in concrete. Here's a column cast in concrete. And in both of those connections, there is an X reaction, so it can't slide side to side. There is a Y reaction, so it can't slide up and down. And there is a moment reaction. There's a resisting moment, represented by this curved arrow, so it can't rotate either. It can bend, of course, further out on the beam or the column it could bend, but it cannot rotate at the place where it's connected. And where do we find these fixed connections? Well, we find them in structural concrete, where you have concrete members that are cast in place. You see a lot of those, well, in lots of commercial buildings are like that. Also, when structural steel columns are connected to base plates, you sometimes see what's called a moment connection. And these gussets here they're not totally welded down, surprisingly, but they do keep they're close enough that they keep this beam from rotating. So that is also called a fixed connection. Here's this structural steel connection we looked at earlier, now with one of the beam connections welded. So this connection which is welded has become a fixed connection because it is no longer free to rotate, while the other framed connection with this beam is still a pinned connection because it is free to rotate. And this column splice that's only bolted, it is also a pinned connection. So those are the three types: a pinned connection, where you have an X reaction and a Y reaction; a roller connection, which could also be slotted holes, notice, where you have a Y reaction only, but it's free to slide in the X direction, so no X reaction; and then a fixed connection where there's an X reaction, a Y reaction, and a moment reaction. And we are not going to look at these guys very much. We're just going to focus on pins and rollers. So here they are. The support conditions defined by what kind of reactions they have. A roller or a rocker has only a Y reaction. A pinned support or a pinned connection has an X reaction and a Y reaction. And a fixed connection has an X reaction, a Y reaction, and a moment reaction. Those are the three types of support conditions.